Hi, welcome back to this channel. In this video, we are going to discuss about the boiling point and also solubility of carboxylic acid. Okay, when we look at the structure of the carboxylic acid, we have the idea that carboxylic acid is a polar molecule. And then this polar molecule is able to allow them to form hydrogen bond between the molecules because there is hydrogen bonded to the oxygen. So this is one of the criteria to enable the compound to form hydrogen bond between molecule. Okay, at the same time, you will notice that alcohol also consists of hydrogen and then the hydrogen also bonded to the oxygen. However, we will notice in this segment here, generally carboxylic acid will have higher boiling point than alcohol due to the dimerization of carboxyl. So there is another structure over here to show that's the meaning of dimerization of carboxylic acid. When two carboxylic acid arrange themselves, they are able to form two hydrogen bonds and make the structure become stronger. Okay, so with this, then we know that here, the carboxylic acid basically is assessed as the dimer. Okay, if there is similar that if for example, if they are all are carboxylic acid, then how we going to know which one have the bigger or higher boiling point? Then basically we look at the molecular size, because when the molecular size is bigger, the contact surface area also will become larger and the van der Waals force will become stronger and make the boiling point become higher. Okay, so if we look at the example over here, we have two ethanoic acid. We have ethanoic acid, methanoic acid, propanoic acid, and pentanoic acid. So generally, all these are carboxylic acid with one carboxyl group, and then the difference among them is the number of carbon. So we know that difference of the number of carbon will lead to different molecular size, and then we will explain relate with the contact surface area, and then the strength of the van der Waals force, and then the boiling point. So if you look at here, they will arrange and then label with the A, B, C, and D. If you think that you don't want to repeat the name of the carboxylic acid in every sentences, then you can label like this. So first again, we relate with the molecular size, contact surface area, strength of van der Waals force, and then relate with the boiling point. So basically in each statement here, we involve all the carboxylic acid. Okay, another question. Here we have ethanoic acid, butane, propanol. So when we look at here, basically they all are from different homologous series. So if they are from different homologous series, then basically we need to identify the intermolecular force for each molecule first. Okay, so for example, from here we know ethanoic acid and propanol can form hydrogen bond. Okay, but then what makes them have different boiling point is due to the dimerization. So what the effect of the dimerization? So dimerization cause ethanoic acid can form more and stronger hydrogen bond. Okay, and then the last one is about the butane, which it is non-polar, and then it only will show weak van der Waals force. Okay, so then maybe there will be a better, we add on another statement. Van der Waals force is weaker than hydrogen bond. Van der Waals force is weaker than hydrogen bond. Okay, however, because from here you already have the word meaning weak, so I think that is okay as well. Okay, now let's continue with the comparing the boiling point in between the different homologous series. So just now we roughly did mention about alkane will form London forces. Okay, so beside alkane, alkene, benzene, because they only have the bond carbon and hydrogen bond, which is non-polar bond. So the whole molecule will become non-polar molecule. So the strength of the intermolecular force is London forces. However, haloalkane and carbonyl compound, they are polar molecule. So, but then they are unable to form hydrogen bond. The intermolecular force that can form between them is the dipole-dipole forces. Then for the amine, alcohol, and carboxylic, all these three can form hydrogen bond. Okay, alcohol and carboxylic we already discussed. So now amine is the one with the alkyl group and then bonded to R. Alkyl group bonded to N, and then they may have the hydrogen. So the hydrogen is bonded to nitrogen, also able to form hydrogen bond. So to form hydrogen bond, there must be a hydrogen bonded to fluorine, oxygen, or nitrogen. So now between amine alcohol, both also consist of hydrogen, can form hydrogen bond. But what makes them have different boiling point is because of nitrogen is less electronegative than oxygen. So the strength of hydrogen bond for amine is weaker. Okay, then next when we compare the alcohol, with carboxylic acid, both are bonded to oxygen. Then what makes them different? So it's because of the carboxylic acid able to form dimer. So when the carboxylic acid can undergo the dimerization, carboxylic acid able to form more hydrogen bond and make the boiling point become higher. Okay, now let's continue with the tutorial question number 4. Butana, propanoic acid, pentane, 1-butanol. Okay, so we notice that they are from different homologous series. One is from different homologous series. Let's identify the intermolecular force. Butana is example of carbonyl, so dipole-dipole. Propanoic acid, hydrogen bond. Pentane is alkane, so it's London forces. While 1-butanol also consists of hydrogen bond. So from here we know that London forces is the weakest among all these. So pentane comes first, followed by butana, and then propanoic acid and 1-butanol. Both are hydrogen bond. But then we, like just now we already discussed, carboxylic acid can form dimer. So the more hydrogen bond. So that's why we will follow by 1-butanol and then propanoic acid has the highest boiling point. Okay, so when here we look at the answer over here, they will focus on in general, you will mention propanoic acid and 1-butanol higher boiling point. It's due to they have hydrogen bond. Then they will mention why propanoic acid highest, because it can form more hydrogen bond due to the stable hydrogen bonded dimer. Okay, means the keyword here is the dimer. Okay, then after we already compare 1-butanol with propanoic acid, then we can compare pentane with butana. So pentane has lowest boiling point because can form weak London forces, while butana have stronger dipole-dipole forces. So basically, when we want to comparing the molecular boiling point in different homologous series, once you can identify the type of intermolecular force correctly, basically you will get quite a lot of the marks already. Okay, just depends on now how you are going to make the sentences. Okay, in this slide we are going to discuss about the solubility. So basically we can discuss solubility in water, and then another condition is the solubility in organic solvent. Okay, so example is the benzene. So when we look at the structure here, we have one molecule carboxylic acid, and then here another molecular carboxylic acid. So this is the water and this is the water. So we can see that the hydrogen bonded to the oxygen able to form hydrogen bond. Okay, so here we can form hydrogen bond. Here we can prove that the carboxylic acid can form hydrogen bond with water. So if they can form hydrogen bond with water, so basically it supposedly will be soluble in water. However, only up to butanoic acid, or sometimes some of the notes will mention is pentanoic acid lah. Okay, so I think it's around first 4 or first 5 member of the carboxylic acid will be completely soluble in water. When the size of the carboxylic acid become bigger, the solubility will decreasing, okay, due to the hydrophobic area getting bigger. Okay, hydrophobic area bigger, okay, if the molecular size bigger. So again, beside from the solubility in the water, we also will focus on the solubility in organic solvent. So carboxylic acid also will soluble in organic solvent due to the alkyl group of the carboxylic acid able to form van der Waals force with the benzene. Okay, so again, from here we know that this is the van der Waals force that can be formed with. Let's continue with tutorial question number 5. Arrange the following compound in order of increasing solubility in water. So the one which is least soluble in water is the propane, followed by propana, followed by propanol, and then the most soluble in water is propanoic acid. Okay, so we will stop the video over here. In next video, we will going to discuss the acidity of acidity of carboxylic acid. Thank you and see you. Bye bye.